All right, I want to talk to you guys today. We already did this. We did it either yesterday or today. We talked about relations and functions. And relations and functions are very, very simple. A relation is relating x's to y's. Okay, I'm going to blow this up just a little bit more so you can see it. I'm going to pull this over if I can. Let me get rid of this. And then I'm going to move it over just a little bit. So you see here that we're talking about x's and we're talking about y's. We're going to call x domain. We're going to call the y's range. We'll get to that definition piece shortly. A function is a relation that has a domain where the x values in your table don't repeat. Okay, so we can't have two x's, like x equals 2 and x equals 2, where you have different y values. Okay, or it's very simple. It's very simple. There is what is called a vertical line test. If you can draw a vertical line through something that's on a graph, say we have a graph and it goes like this, right? That's our linear equation. We're going to be talking a lot about linear equations today. If we can draw a vertical line through it at any point of that graph, then we know that that's a function. But we'll get to that. That's not really, really, really important yet. Right now, we just need to know that the x's don't repeat. So if you're given a bunch of coordinate pairs, like you are at the bottom of this page that we're going to take care of, we're going to look, and we're going to look at all the x's. Do any of the x's repeat themselves? And if they do, then it's not a function. All right, so that's really the super simple piece of it. The one-to-one function is what we look for most of all. We can say that the onto function, we don't always have an onto function, but it does exist. The onto function is something like our parabola, our quadratic. That's an onto function, right? Because for two different x's, you're going to get out the same y values here. Okay, and that's not a big deal. It does exist, but it's not linear. It can't be linear and be an onto function. So we know when we start talking about linear functions, we're talking about one-to-one. Yes, sometimes we can have, a lot of times they talk about for all these x values, we have a unique y and the same number of range values. Forget both. I want you to understand one-to-one functions, and I want you to understand onto. One-to-one are our linear functions, and onto are our other functions, our quadratic functions, anything that curves and bends and swoops. Those are onto functions, and you'll get to those later on, but we're really going to focus on linear functions right now. Okay? So let's go ahead and move on and start looking at our exercises at the bottom. I just have to shrink this down a little bit. All right. State the domain and range of each relation. The domain is a list of all the x values in our coordinate pairs. And everybody understands that a coordinate pair has both an x and a y. Here's your x, here's your y, all the way through, right? And so our domain would be 0.5, 0.4, 3.1, and 0.4. And our range would be, sorry, I gotta get that out of the way, 3, 2, 1, and 0. Okay, so we've listed our domain and our range, and we look at it and we say, okay, we want to know if this relation is a function. All right, so we take our colored marker and we underline any x's that might repeat. I have 0.5, that doesn't repeat. Look, my 0.4 has a repeat there. So we know right now that this is not a function. So we'll go back to this and we'll say, no, It's not a function. How dare they? Whatever, stuff like that. All right? And so you can go through the rest of these, listing your x's as your domain and your y's as your range. And we don't really bother with range when we're talking about functions. We really just need to know about the domain. Onto means your y's repeat, and that's this one here. All right, so that's not a function. Let's do number 4, and I'm going to list my domain. Domain is -15, -14, -13, and -12. And since we've written it out and we see that none of the x's have repeated, we know we have a function. So we say, yes, it's a function, but let's find out which kind. Now, if the y repeats, if one of the y's repeats, then we know we have an onto function. That's the difference between the two. Oh, look at that, my 12's repeat. Yes, it's an onto function. Sound good? It's a very simple idea, all right? So let's go back and look at these other guys. Domain, -5, 4, 3, and -7. And I didn't put them in order. I should have put them in ascending order, but I didn't. I just wanted to check my range. So this is a function, yes. None of those repeat. My range. All right, I have a 2, I have a -2, I have a -11, and I have a 2. Hey, look at that. The 2's repeat. Just like the one below it, we have an onto function. And last but certainly not least, let's take a guess, because they're going to give us a one-to-one function. Here it is. But let's go ahead and write it out. My domain is 0.5, 0.1, and 6. My range is -3, 12, and 8. No x's repeat, no y's repeat. We have a one-to-one function. Okay, that's a different way of writing one-to-one. It's a ratio, 1-to-1. Make sense? Great. Let's move on. The next part is looking at something that's written in function form and then doing some math because we're given a value for that function. Let me erase this, and then I'll move this along. Give me one brief moment. Here we go. There it is. All right? Here it is in function form. Equations are relations and functions. They represent functions that are often written in function notation. This is function notation. You've seen it before. I'm going to blow it up just in case you haven't seen it before. Get used to it. This is Algebra 2, kids. This is the be-all and end-all right here. A function of x, which means something that happens, and the x is our variable, that input that we can put in, our dependent variable, right? We need to know x squared plus 2x, right? And then it says, what happens if we have a function of 3? Say it's 3 seconds. And every second, this is squared, and then you multiply by 2 and add those two together. Okay, well, maybe that's true. So here's our function. We decide what happens at 3 seconds. Okay, well, I'll put in a 3 for the x, and I'll do the math. So here's our original function. F of 3 means I put in a 3 for the x, and I square it. Then I put in a 3 for the x, and I multiply it by 2. 3 squared is 9. They didn't do this math for you. 3 squared is 9, and 2 times 3 is 6. 9 plus 6 is 15. Is that a big deal? It's not a big deal. It's actually very, very simple. All right, so that's function notation. If you need to go back and look at it again, all we're doing is f of x gives me the actual function that I'm going to replace x with. when we're given values. And here's the other type of value you might be given. For now, they may give you a variable term. What happens if? What happens if they say, we're going to use this same function, but what if we have f of 5a? Okay, well then we just simply put in 5a for our x. We still square it, just like we squared the 3. And we put in 5a and we still multiply it by 2. Okay, well that's great. 5 squared is 25. A squared is a squared. And then we're going to add to it 2 times 5a, which is 2 times 5 is 10, times a is there. We're done. And we can't put these together because they're not like terms. That's really as simple as it gets. There's nothing else you need to do. We are all set.